All right, well, happy Monday. Happy week 5 Monday. All right, we'll look at pandas. I know some of you guys were using pandas at DataFest, which is great. But I'll introduce it now. I hope it's not too late. But basically, pandas is the package or the library or module that we load into Python that allows us to work with a data frame, right? And so data frames are these two-dimensional structures. They're basically tables, and each column, a table consists of columns, and each column is basically a NumPy array. Everything has to be of the same data type, okay? So Pandas creates data frames. Each column in a data frame is a NumPy ND array, and so this kind of allows us to have these traditional tables. All right, your very important resources will be the documentation on series and data frames, okay? So read up on the pandas.dataframe and pandas.series. So basically the columns are called series in pandas. And we're going to spend pretty much this entire week just talking about pandas and the stuff that you can do with pandas. Okay, all right, so to get pandas to work, you got to import NumPy and pandas, and the convention is abbreviate NumPy as NP, abbreviate pandas as PD, and that's what we'll have there. Okay, so we'll start off with just kind of talking about one column, okay, and that's known as the pandas series. Okay, so a data frame in pandas. So the data frame is the primary structure, okay, that the important structure that you're going to be using in pandas. But but a data frame is built out of series, so it's going to be important that we understand series first. Okay, but I would say it's not as common to be working with pandas series directly, if that makes sense, right? I mean, you will be working with pandas series, but usually it's because you've subset a data frame rather than dealing directly with the series in of itself. But anyway, one thing to keep in mind is that all series and hence all data frames have an index associated with it. Basically, index is kind of like row names. Usually they're integer indices, but it's not always that. But you can kind of basically think you have some kind of way to reference a row other than just position. Okay, so here we'll create a pandas series, pandas.series, and then you put in your data. You provide an index if you want. Otherwise, it will automatically create an index for you. So here I'm going to just give it this list, 0.2, 0.5, 0.75, 1.0. And then it's going to convert that into a NumPy array and make a pandas series out of that. So I'm going to print out what does that series look like, and I'm also going to ask what is the type it is, right? So this is when you print out the series, we have those numbers, and it also has automatically created my index. It's just a range index, 0, 1, 2, 3. And then you can see the type is, it says class, and it's a pandas series. It's a pandas.core.series.series, but basically just a pandas series. There is a difference in how things get displayed and output. In Jupyter, if you call print on a series, it prints it out like this, okay? And then if you just ask for the object itself, it looks almost exactly the same, okay? It gets output like this. So here it is, so That's what we have there. Okay, so print.data outputs like that, and when you just call for the series itself, it looks exactly this, almost exactly the same. There's a distinction between, I guess, printing a data frame, calling print on a data frame, and then just asking for the data frame in Jupyter. Okay. You can also once you have the series have these attributes. One is the values attribute, and the other is the index attribute. Okay, so you can say, hey, what are data.values? Okay, the values are basically 0.25, 0.5, 0.75, 1.0, and it's those are stored basically as a NumPy array. So when you ask, hey, what are the dot values, and you ask, what's the data type on that? That's a NumPy array. Okay, what is the index? The index is going to be this part, 0, 1, 2, 3, right? And here, because Pandas created it automatically, it creates what's called a range index, basically a range object, but it's specifically a range index object. And if you say, hey, what is the data type on this thing? It's just going to be a pandas.range index, basically. Okay, so you have different kinds of indices. Probably the most commonly used one is going to be the range index. Just number them. All right, you can subset a pandas series just like other Python objects, just like NumPy arrays. So if I say, hey, what is data square bracket 1? That's going to give us the index 1 object, 0.5. What's the type on that? If you select only one value, it's going to kind of just simplify it just to that value type. So this is just a float. Okay. You can slice it. So 1:3. That'll give us the values 0.5 and 0.75. And because here I sliced two values out of the series, I get a series of length 2. It is not just a NumPy array. It's not a NumPy array consisting of 0.5 and 0.75. It's a series with the values 0.5, 0.75 in it. Okay, and if you say, hey, what's the type on that? That's a series. You can also do what we call fancy indexing, in that if I take this list or this NumPy array, and I say, hey, give me index 1, index 0, index 1, index 2, you can do that, and you get those values back. Okay. If you want, you can specify your own index. So if you don't specify anything, it's going to create a 0, a range index starting at 0. That's the default behavior. But here I'm going to specify my index myself, and I'm going to say ABCD is the index here. Okay, so we're creating an entirely new Pandas series. I call it data though. Same, just replacing the old data object. Okay, the data.values, same, it's the NumPy array. The index here is now I get an index object with the letters A, B, C, and D. Okay. One thing you'll note, D type here is object. You might have expected data type to be series. Not series, string. Okay, because we got the letters A, B, C, and D. And so in Pandas, strings are often called D-type object, and that's because Pandas allows for missing values with the nans in strings. And so if you try to, nan is generally a float, but in Pandas you can have strings, and then when you have a missing value for a string, it will put in a nan. And so kind of this mixed thing between strings and nans is going to be data type object. Okay. All right. If you have an index that's not 0 through whatever the range index, you can try to pull this out. Okay, and here it's giving. So I'm subsetting via position, and I get this warning here, right? It says it's a future warning. It's saying, treating keys as positions is deprecated. So this is kind of something that Pandas is allowing us to do right now, but it's saying like, hey, you know what? We're planning on getting rid of this. We want you to get in the habit of just kind of like a dictionary, only using the thing. Okay. Now, so this is, we didn't cover like virtual environments in this class, and I don't know if I want to get into that. I guess you can look up stuff on virtual environments, and also Anaconda or Conda handles different kind of environments and things like that. But this is a common issue in Python, is that you'll write some kind of script and it'll work for whatever you have. But then when you bring it to a new computer or you update your software, it breaks, because this kind of stuff often happens. Most of the big packages give you nice little warnings that says, hey, we're planning on changing this feature, and this thing that works now is going to stop working in the future, so just be ready. But a virtual environment will say, hey, this is this version of the software that I'm using. I'm using version, whatever, 3.2.7 or whatever, and it will load that thing up. Okay, but anyway, that's what we have. It's kind of like I don't know, if you're talking about some movie, you have like the theatrical release, and then the director's cut, and the extended version, and the Jack Snyder or whatever. The Snyder cut and things like that, right? Blade Runner has notoriously like so many different things, and it's like kind of like, oh, this only makes sense if you're referring to this exact version, and it's kind of like that. But now you have like 50 versions of Python stuff. Okay, subset index with the index name like A. That's fine. Okay, you can slice. Based on position. Okay, you can also slice based on kind of the names, right? So here I can say slice from A through C, okay, and it will do that. Okay, now when you slice based on kind of the names, notice that it starts at A, goes up through and includes C, which is different than like slicing based on position 0:2. So that's what we have there. Okay, I created a little dictionary. These are based on the, I guess the Avengers. A bunch of these people have retired from the after Endgame. Oh, sorry, spoilers. What's the time on spoilers? 5 years, I think, is enough, right? Yeah. Okay. Or anyway, all right. So here we have the I guess their character's name, and then the actor's name, and I've created a series out of this. Okay. So here I've created a dictionary, and then you can take the dictionary and you can say make a series out of the dictionary, and what it will do is it will take the values and make values. And it will take the keys and turn those into the index. Okay, so the keys became the index, the values became the values. So right now our values are actor names. Okay, and then so here I can say, hey, what are the index? The index is the keys. The values are the values, and these are both kind of index and whatnot. All right. So I put Avengers ages during the first Avengers film, which I think this is what they were saying. All right, I don't have an exact source on these things, and so apparently in 2012, Tony Stark was age 42. I don't know. All right, and Thor was 1,493 years old. Man, what are you supposed to? How is he that old? Okay. All right. All right. So you have this. So here's our series. Basically, the values now are that. Okay. And then I've got I'm going to create another dictionary, and these will be their superhero names. So Steve Rogers is known as Captain America, and so on and so forth. Okay, and Thor that's just his name. I don't know if he doesn't have a separate superhero name. Okay, so that's that. Okay. These are all in, okay, yeah. So now I'm going to create a data frame, okay? Now notice, before I create the data frame, I just want to kind of point this out. This one, the order of the index is Tony Stark, then Steve Rogers, going down, okay? Here, it starts at Thor, and I think both of these are in this order, but basically, this series as the index order is different from this series index order, okay? But what I'm going to do is when I create a data frame, I'm going to join all of these up, okay? I'm going to say make a data frame, and I have a dictionary of the different series, okay? The dictionary here, the key is basically going to be my column name, and then the value is going to be the corresponding series. So I've got actor, hero name, and age, and I'm going to make a data frame out of this. And when I do this, it matches up the indices, okay, and it creates the corresponding data frame. So now I have column actor, hero name, age. The index is now put in alphabetical order, okay? So when you get, if the input series, so here, this was in a different order from here, then what Python does is it puts it in alphabetical order, or pandas, okay? So, we got Tony Stark, Steve Rogers, Natasha, Bruce, Thor, Clint, and this is a different order here. It's going to put them in alphabetical order. Now, if both of the series came in the same order to begin with, then I do believe pandas will preserve that original order for the series when it creates the data frame. But here, because I had different orderings, it matches them up and then puts the index in alphabetical order. Okay. All right, so if you ask what's the type on this, it says that's a data frame, and we have that. Okay, so this was creating a data frame using a dictionary with column names as keys and series as the values. Okay, you can also create another dictionary, or I guess another data frame out of. Here I have a list of dictionaries, okay? So I have A is 0, B is 0, A is 1, B is 2, A is 2, and B is 5. And what this will do is it'll create a column for A, and it'll create a column for B, okay? So here's my list of dictionaries, and I'm going to say make a data frame out of this, okay? And when I do that, this is what I get. I get a column for A and a column for B. Here I have kind of a mismatch. I have A and B, and then I have A and C, right? So if I do this, and I say make a data frame out of that, I'm going to get 3 columns. I'll get column A, B, and C, but then I'm going to get NAs for where the places where I don't have values, okay? I think that makes sense. You can also take a dictionary. Here I have basically key A, key B, and then I've got values, kind of these lists here. Here the arrays need to be of the same length in order for you to make a dictionary out of that. So this is kind of, I guess this would be the most similar way to creating a data frame like in R. So if you make a data frame in R, you might create like a, you say data.frame, and then you say like the column name, and you give it a vector, column name equals vector. And that's that will look most similar to this, okay? Basically, you give it a dictionary of column name vector, and you do that, okay? Okay. Oh, so here's, I forgot to point this out. So here when you call print on a data frame, it outputs in kind of this typewriter text, monospace typewriter text. So here I've been calling print on the data frame. But if you just call the name of the data frame, it will kind of pretty print it. I don't know what you call this, okay? So one is calling print on the data frame, and it will output like monospace typewriter text. And then if you just call, if you don't call print on it and you just ask for the data frame directly, Jupyter will output it as kind of this, I don't know, nicely formatted thing with column names in bold and the index in bold as well. And same as what's going on over here. So here I called print on the data frame, and over here I just ask for the data frame directly. All right, let me give you your first view quiz answer, which is the letter A. A is your first view quiz answer. All right, here I've intentionally made a mistake. I say here's the dictionary. A has 1, 2, 3, 4, and B has X, Y, Z. So these arrays aren't of the same length, or the lists aren't of the same length. And so if you try to make a data frame on that, then it's like running and running and running. Eventually, I think it'll, okay, finally, it kicks back and you get this long error message, okay? So this is the one thing that's bad about pandas, all right, is that the error messages get much harder to read, okay? So like Python, in general, when you are like writing your own little functions, the error messages are very nice and clear and points out like exactly where things went wrong. But in pandas, you have all of these kind of different pieces working together. So you have like the frame and the construction and things like that. And so like this calls this thing. And so like trying to trace all of this is really hard. Thankfully, they do understand some of these things. And so here it says raise a value error. All arrays must be of the same length. And so that's actually helpful for us because we gave one of these, when it's trying to construct the data frame, it recognizes where it went wrong. But sometimes the error that you get is going to be very cryptic and hard to understand. So when that happens, what you do is you highlight it, and then you go to Google, and then you search, okay? And then usually it will tell you, like usually you can find some kind of corresponding entry on Stack Overflow or something that tells you what went wrong, okay? And I think that's fine. I think everybody, I don't think Pandas is localized to be in different languages. I think it's English for everybody, or is that not true? I don't know. Is there like a localized, like, do you get error messages in a different language if your computer's set up in a different language or something? I don't know. Well, anyway, this is very ethnocentric, but I always say set your language to be English, okay? And that way you can copy and paste your English error language message, put it into Google and search for it, and you'll find lots of results corresponding to that error message. If, like, one of the things in R is you can localize it so it reports error messages in, you know, whatever your native language is, which is great. However, when you do run into a problem and you try to search for that error message, you're going to get a lot fewer help on the internet than you would if it wasn't English. So I always say, you know, search for your English error message. But I mean, that's easy for me because native English. So it's like, oh, of course that's, but you will find a lot more kind of results for English error messages. Okay, what was I saying? All right. Oh, and then the other thing is, okay, so you can take a NumPy array. So here's a NumPy array, and you can just give it like column names and stuff like that. And so you can take this array and make a data frame out of that. And so to do that, you just take your matrix, you give it column names, X and Y. If you want, you specify index names, and there you go. If you don't, Pandas will automatically, assign a range index for you, which is totally fine. Okay. All right. Let's work with this data frame that we have. All right. So you can ask, what are the column names? All right. So you do avengers.columns, and here it says your column names are actor, hero name, and age. Ask what's the index. The index is the names of our characters. Okay. And then and you can select any of these things using dot notation, or you can also use single square brackets to select your columns. So here, if I say avengers.actor, it will pull out the actors column. Okay. If you have a space in your column name, then you have to use square brackets. Right? So in general, don't put spaces in your column names. Okay, it's allowed, but you don't get to use dot notation. And dot notation is like, it's way nicer. Okay, so I think so we have that. Or I don't know. Let me see. Can I do Avengers dot? Does this work? Hero name? Maybe. No, it doesn't like it. Yeah, okay. Yeah, you got to do square brackets. Wait, no, not dot. Yeah, okay. All right, and then when you ask for it, it's a series, right? Okay, same thing. Zero-based indexing based on position, but again, the series it doesn't want to be treated as positions, so use that. Okay, you can kind of combine to kind of subset things. So I can say, hey, give me the actor where the age is equal to 42, right? So I can do avengers.age equals 42. All right, and we get trues and falses. All right, and then so I get this series of booleans, and then subsetting corresponding to that, then we get just those rows where this is true. Okay. You can also say, all right, give me here the Steve Rogers is the index, so I can say, hey, give me the hero name where the index is Steve Rogers, and then we'll give Captain America. And then you can also kind of slice using that as well. Hero name, Steve Rogers through Tony Stark, and you get that. And this is just as it's stored currently in the data frame, which is in alphabetical order. The when you have a data frame, one of kind of the most common things that you'll use is the location attribute, okay? And so here, you can call data frame name, whatever it is. So in our case, our data frame is called Avengers. So we do Avengers.location, and here it just says, hey, I want the row corresponding to Thor, okay? And so I get the row corresponding to Thor. I get back a kind of this series, but it transposes basically the values in that row, okay? So, column, actor, hero name, and age, and it gives us the corresponding things, okay? The type on this is it is a series, and the values are an array, and you might go, wait a second. These are, here I've got integer, and here I've got a string, and I thought you said NumPy arrays can only have one data type. And that is true, with the exception of something called a structured NumPy array. Okay, and a structured NumPy array says the first value will always be this data type, the second value will always be this data type, and the third value will always be this data type. And so if I said, you know, Avengers.location, I don't know, Steve Rogers. Okay, this has the same structure as this, right? So we've got string. I guess this is object, which is a mix of strings and nans, and then age, which would be integers. Okay, and so structured NumPy arrays do allow for different data types, but you do, like in the creation of a structured NumPy array, you have to specify exactly. It needs to have the kind of security that in this position it will always be this data type. Okay, here I can say, give me all the rows and just the column for age. Okay, and so you can do it that way, which feels strange. Like, why would I do this if I can just call Avengers.age? You could do that too. Okay, so dot location, basically all the rows. So colon before the comma, the column that corresponds to this. Here I can say what's the type on that, what are the values, and you can kind of just get one thing. You can say give me Steve Rogers and age. You can also, so you can do that, and I don't know, what were the other columns I have? Hero name. So you can also, you can slice both ways, right? So oh, single quote, double quote. There we go. Okay. So you can say, I just want these rows and these columns, or something like that. Okay. All right, so that is .loc. You also have something called .iloc. Okay, .iloc uses index position to do this, right? So .iloc, you can say, hey, give me the index 3 row. Okay, this you can say, give me iloc, give me index row 0 and column index 1, and you get that. Okay. And just like any of these other things, you can give it, say, I want 0 through 3 and 1 through 3 or something. Okay, and you'll get the corresponding values. Okay, you can also assign use iloc or loc with assignment to change your values. And so here I'm going to change Thor's age to 1500, and right now Thor, so if we look at the current table, so right now Thor's hero name is missing, and I can kind of specify that. So I'm going to just change his age and change his hero name. Okay, and so I'm using change .location Thor and age from 1493 to 1500. .location Thor and hero name from Nan to Thor. Okay, and so if I do that, now we can see those values have been changed. And then you can also kind of assign things multiple values at once. So I can say, hey, I want to change Thor, hero name, and age. We're going to do np.nan. We'll replace it with a nan and 1493 to get back kind of our original values there. All right, let me just show you kind of one of these subtle differences between .loc and .iloc. All right, so if you have a range index, that starts at 0, .loc and .iloc are going to have the same behavior. But here I have a numeric index, but this one starts at 1. Okay, and so .loc always uses the actual index. So if I say dataframe.loc1, it will give me back this row, 11 and 2. Okay. If I say .iloc1 will say always uses a zero-based index. So the first row is 0, and this row is row index 1 for .iloc, okay? And so this, if you aren't paying attention and you happen to have a numeric index that's not zero-based, it's easy to get mixed up and not realize what's going wrong until like you're like, oh yeah, my numeric index doesn't start at 0, right? And this is, I would say this is like even more problematic when you're switching between Python and R. Like if you get in like, I'm gonna stay with Python and you use it for like 6 months, then like starting things at 1 feels unnatural after a while. But switching between Python and R, like I get messed up all the time. So just a warning there, okay? And then here, if I say, hey, give me iloc 3, there's no iloc 3, right? Because it goes 0, 1, 2. There's no row 3 if we're using iloc. Okay. Second view quiz answer, is that right? Okay, second view quiz answer is E. E as in elephant. E. Okay, so this is kind of how you filter for rows and stuff, is you'll use like your Boolean operators. So I can say I want where age is less than 50 and age is greater than 40, okay? And so because I'm using a vector, this is going to return a vector or a NumPy array of Boolean values, and this will also produce a NumPy array of Boolean values, and I want to combine the two. I use the ampersand, okay? This is the bitwise AND operator versus, because Python also has the word AND, but you don't want to use that, okay? You want to use this, okay? So here I'm going to say, hey, I want where this thing is true and that. So apparently prime Avenger's age is 41 and 42, I guess, unless you are Thor. He's got to be the same age, right? Are they all the same age there? How old is Loki? Okay. All right. You can also, I mean, there's you have these like nice little string operators, right? So you can take the index and then .str, okay? So you can take the index. .str gives you access to basically string-based functions, okay? Like starts with B or whatever, okay? And you have that, right? So give me the index that starts with a B and you'll get that. What else is there? Here, let's see. Pandas index str, string index, pandas index.str. Ah, I want more. Well, okay. String split and replace. We have vectorized string functions. Okay, well, I was hoping it would give me the list of all of these things. Okay, but you have like string.find, so you can find all of these things. Okay, so what does this thing do? Well, I guess I guess my comments will tell you, right? But remember, so if you do string.index, it will look for the thing and it will give you back the index of the thing. But then if it doesn't find it, string.index will return an error, okay? When you like search for in a string, if you look for the index of something, you give it something that doesn't exist, it gives back an error. Whereas if you say .find, if it finds it, it gives you the location or the index location, but if it doesn't find it, it will give a -1, okay? So here we're gonna say search for a capital R, and if it doesn't find it, that's a -1, but we don't want it where it's a -1. So basically give me where the names contain the capital R, okay? So we're gonna get Natasha Romanoff, Steve Rogers, they have a capital R in their name, and we have that. Oh man, okay. Steve Rogers was 104 and Black Widow was 28. And they set them up for like, there's some kind of tension in that second Captain America movie, right? But well, whatever. All right. Well, and then they shipped her with Bruce Banner. I don't know, whatever. Okay. And then they killed her off. Okay. Spoilers. Okay. Oh, you can transpose a data frame. This is not. I don't know how often we ever do this. Do we ever transpose actual data frames in real life? I don't think so, right? But it exists. Okay. Data types. All right. What are my column data types? All right. I mean, this is always useful for like summary information, right? Shape's always useful. All right. I showed you like 4 ways to create a data frame today, but let's be real. We're not going to make a data frame. Okay. Not that way. You're gonna read in a CSV. Okay. You're gonna read in a CSV. So this, what do? You call .read CSV or .read_CSV. You give it the name of a file. All right. You can also put in a web address like a URL. I mean, really, that's just the name of a file, I guess. And so here's the Titanic data set, which is, I don't know, I guess, is this interesting? Titanic. Some people are obsessed with the Titanic, like James Cameron. Like, I guess he made a movie, and so, but, and then like the people, they went down into the sub with the, I don't know, that's unfortunate, but yeah. Okay, so anyway, here's the Titanic data set, and we have passenger ID. Look at this, passenger ID, and then we have our zero-based range index. So it's just one is one greater than the other. Just be careful. Okay, and then it's got information on whether the passenger survived or died or something. It's kind of a grim data set, I guess. Okay, all right. How many rows? 891 rows in this one. There were more people. Where did everyone else go? Okay. These are the column names. You have the index. Okay, .info will give you like kind of some summary information. I guess it's more than just data type. Okay, D types will give you this. .info will give you even more information, kind of like how many values are not missing, which is handy. Okay, so we have some missing values for age, and then describe. What it will do is if it's a numeric thing, so not the object one, so you'll see there's nothing for the object ones, but all of these things that are numeric type, it will calculate things like your mean and standard deviation and things like that. So only the numeric ones. So survive P class. So I mean, you got to kind of be careful, right? Passenger class is really a categorical variable, but because it's stored as a 1, 2, 3, it just averages them, stuff like that. Okay, there you have that. All right, so that is our introduction to pandas, and we will we'll end here for today, and then we'll see more pandas stuff on Wednesday and Friday. Lots of stuff to cover in pandas. So, all right, let me cut our video here.